Hi there. Hope you have a fantastic day today. This lesson I'm going to teach you rates of change. Of course, there's a PDF file version on the description below for you to download if you like, so you can work with me. Otherwise, let's go straight into it. First one. The diagram shows a conical slope spencer of radius 5 centimeters and the height is 20 centimeters. So you can see the diagrams has all the information you need. So part I, explain why R is equal to H over 4. To do this part of the questions, what we need to do is we're looking at the similar triangle. So if we connect the height all together, so we have two right angle triangle here. So we have a smaller one and a larger one. So let me just draw it out here. So we have a larger triangle. So that is 20 centimeters, and which is 5 centimeters is the radius. And the smaller triangle is this. So we have the radius, which is R, and H. And of course, these are corresponding angles. There you go. So now we just use similar triangle ratio, okay? So if we go R over 5, because these two sides are corresponding. So then equal to H over 20. So if I times 5 on both sides, so this will give me, this cancel out. So therefore, R is equal to, now I can simplify this, give me 4. So that means R is equal to H over 4. So I just write here. Therefore, R is equal to H over 4. There you go. Part 2. Show that dV dH is equal to pi over 16 times h squared. So to find dV dH, first of all, we know the volume, okay, of a cone, which is 1 over 3 pi r squared h. Of course, from part 1, we know that the radius r equal h over 4. So we can just replace r with h over 4. So just put them in. So pi, and then this is h over 4 square and h. So if I simplify this, and now that is just the same as 1 over 3 pi h square and over 16 times h. And that is equal to pi h to the power 3 over 3 times 16 is 48. This is the volume. So just write V equal. Now we just need to differentiate it, okay? So I just move this up a bit. So therefore, dV dH is equal to, we bring the 3 down, and then that becomes 3 pi h squared over 48. Of course, we can simplify this. That's give me 16. So therefore, this is equal to pi h squared over 16. So this is the same as pi over 16 h squared. There you go. Part 3. The Spencer has a leak which causes soap to drip from the container. The area of the circle formed by the top of the surface of the soap is decreasing at a constant rate of 0.04 square centimeters per second. So this means that this is the area is decreasing. So dA dt, which is equal to negative 0.04 square centimeters per second, because it's decreasing, okay? Now to find the HGT, So first of all, let me just write this down first. So dh dt is equal to, so we have dh, and then this is dt. And we know that di dt is equal to this. So that means we can use di. Okay, so we just write di here. So this is di, and this is di. And we already know di dt. And we know that the area of the circle formed by the top of the surface of the soap. So that means a circle is been reducing, okay, at a constant rate, which is negative 0.04. So we know that the area of a circle is pi r squared. But then we need to find the dh. So therefore, we need to write area in terms of h. So from part 1, we know that r is h over 4. So now we just replace the r with h over 4. So that pi h over 4 all square. So that will give me pi h squared over 16. And then if I differentiate this, so I'm just go di dh. So I bring the 2 down, become 2 pi h over 16. And if I simplify this, that give me 8. So therefore, okay, this will give me pi h over a. So this means that dh dA is equal to 8 over pi h. Now we just substitute back into this equation here. So that will give me dh dA is equal to 8 over pi h. And we times dA dt, which is negative 0.04. So that will give me, so 8 times 4 is 32. And 2 decimal place. So that means negative 0.32 over pi h. There you go. So that is dh dt. Part 4. What is the rate of change of the volume of the soap with respect to time when h is equal to 10? So we need to find dv dt in another word. Okay. So let me just write this down. dv dt. So that is dv times this is dt. And we already found from previous part, we found the dh dt. So therefore, we can just use dh, okay? So this is exactly same as dh, and this is dh. And we already found dh dt. So what we need to do is we just need to find dv dh. So we know that volume of a cone is 1 over 3 pi r square h. And we want to write in terms of h because we need to find dv dh, okay? And we know that from previous part of the question, we know that r is equal to h over 4. And now we just replace r with h over 4. So that will give me 1 over 3 pi r squared, which is h over 4 squared times h. So this is equal to pi h to the power 3 over 48. So now we just need to differentiate it, okay? Now to differentiate this, we just write dv dh, which is equal to, so bring the 3 down, so which is 3 pi h squared over 48. So now what I do, I just simplify this. So you divide this by 3, so that will give me 16. So that will give me, I just move this up. This give me pi h squared over 16. Now we just replace dv dh is equal to pi h squared over 16. So let me just write this down. So this will give me pi h squared over 16 times dh dt. So from this part here, we know that dh dt is equal to this. So what I do, I just time by this, okay? So now I just simplify this. 0.32 divided by 16. So that is 0.02. So let me just write this down first. Equal negative 0.02, and this pi cancel out and this h cancel out. So 0.02 h. So that is dV dH. But we need to find dV dH at h is equal to 10. So therefore, okay, dV dt at h is equal to 10. So that will give me negative 0.02 times 10. So that will give me negative 0.2 cubic centimeters per second. Please pause the video and try this one yourself. Hi, I'm back. How do you go? So let me go through it with you, okay? So first one. So we need to show R is equal to a third of H. So to do this, we need to use similar triangle. So first of all, let me do part I here. So we know that there are two triangles. So we have one triangle here. This is right angle triangle. And then we have a smaller one here. And there you go. So we just use similar ratio to work it out. So we know that R over 4 because they are corresponding size, okay? And then we have H over 12. So what I do, I just times 4 this side and we times 4 here. That cancel out. This give me 3. So that is R is equal to H over 3. So which is equal to a third of H. There you go. Part I. Part 2. So we need to find dH dt because we need to find the rate at which the height increasing when the height of the water is 9 centimeters. So we need to find dH dt. Let me just write this down. dH dt, which is equal to dH, and we times dt. And we know that dV dt is this. Okay, it's positive because the water is being filled. So therefore, let me just write this down. So we know that dV dt is equal to 3 cubic centimeters per second. So now we just use dV. Okay, so this is dV and this is dV. And we already know dV dt. So now we just need to find dH dV. And we know that volume of a cone is this. V is equal to 1 over 3 pi r square h. But because we need to find dV dH, so therefore we need to write the volume in terms of h, okay? And we know that the radius equal h over 3, or a third of h if you like. So now we just substitute that in. So 1/3 pi, and then h over 3 square times h. So 1 over 3 square is 1 over 9. And we times 3, give me 27. And pi h to the power of 3. So now we just differentiate it. So differentiate this. So we go dV dH is equal to, we bring a 3 down. And that is 3 over 27 pi h square. And then now we just simplify this. So that will give me 9. So that is equal to pi h square over 9. So therefore, dH dV, we just reciprocate this. So dh dv will give me 9 over pi h square. So now I just substitute that back in here. So that will give me, so that is 9 over pi h square. And then we times by dv dt. And that is 3 cubic centimeters per second. So that will give me 27 pi h square. And then we need to find the rate at which the height is 9 centimeters. So therefore, let me just write this down. So dh dt at h equal 9, that is 27 over pi times 9 square, which is 81. And we just simplify this, okay? So if I divide by 9, give me 3. Divide by 9, give me 9. Cancel this out. Give me 3. So the answer is 1 over 3 pi. And because it's in centimeters, so therefore centimeters per second. There you go. Thank you so much for watching. Bye.